Welcome back to our class. We shall continue on examples on Lorentz series expansion. We have considered some examples in the other video. Now we are considering more examples. I want to find the Lorentz series expansion of this about z is equal to 4. Now, we are having z is equal to 4, which means z minus 4 is 0. So I told you the best thing is you make u to be z minus 4. We have it here. If you make z the same formula, z will be equal to u plus 4. Now let's put it here. Therefore, our f of z is exponential 3z. This is our z here. U plus 4 over u raised to power 4. This will be exponential 12. If you are applying this, is times exponential 3u. 3 times 4 is 12. So we have u raised to power 4. So we are left with expansion of exponential u. And we have known about that before. Exponential x, you know, is 1 plus s squared over 2 factorial and so on. So in that case, we are going to have exponential 12 over u raised to power 4. You may not decide to use u. You can use any letter to represent it. Now if you expand this, it will give us 1 over 1 plus 3u. You know, it is our x plus 3u squared over 2 factorial plus 3u cube over 3 factorial plus 3u raised to power 4 over 4 factorial and so on, which if we simplify, we are going to have 1 over u raised to power 4 plus this one will give me 3 over u cube. If we use this u to expand it, plus, you know, this is 9, that will be 9. The u square will cancel this u4. There's no more u square here again. It will be 2 factorial u squared. This one will be 3 cube is 27 over 3 factorial. This u cube will cancel this u4. We have u left. And finally, here we have 3 raised to power 4. That is 81. u4 will cancel u4. So we have over 4 factorial. I believe the next one will have been 3 raised to power 5 ordinary u plus infinity. 3 raised to power 5 is 243. So we cannot bring back our z. So this is our u. Our u is z minus 4. So this place is 1 over z minus 4 raised to power 4 plus 3 over z minus 4 cube plus 9 over 2 factorial z minus 4 squared plus 27 over 3 factorial z minus 4, this one, plus 81 over 4 factorial, we can simplify it, plus 243 z minus 4 plus infinity. So this is the Maclaurin series expansion. The Lorentz series expansion. You will not discover that 1 over this principal part, that is over z here, has stopped in this place. The remaining one are the analytical part. So we have a finite principal part. So we can say that since we have finite principal part, then z is equal to 4 is a pole. It's a pole of order 4 because of this power of 4. So let's take another example. Example 2, expand this function in a Lorentz series valid in this region and this. Now, our f of z is given to be 1 over z minus 1. So valid in this region. So in this case, I can write this thing as 1 over z. This thing can be written as minus 1 plus z, which later I can bring this minus, I can multiply both sides by minus, so that I will have 1 minus z. That is this by minus, this one too by minus. Minus has cancelled this, it has become plus, this one has become minus. Now, what we are going to have there is 1 minus 1 over z is here. 1 over 1 minus z, that will be 1 plus z. Plus, you must know all this, plus z squared plus z cubed to infinity. Which, if we expand, it will give us this plus 1 plus z. There is a bracket here because of this minus, plus z squared plus infinity. So this is the Maclaurin expansion for this one. But for the second one, absolute value of z is greater than 1. In this case, we can consider this in the, what we consider is z is less than 1. But what we are giving here is this. So the only thing for convergence, what we can do is that we take to turn this thing to minus, to less than. This is what we do. 1 over z is less than 1. That means you have to consider something of this nature. And what that means, let me explain it here. Z into z minus 1. You remember in this place, because I have considered z is less than 1. That is why we made this minus, this 1 here. But in this case now, this is what we are going to do. We are going to first bring this one out. This is what we are concerned about. So from this place, you factorize z out when you are dealing with this. If you factorize z out, we have 1 minus 1 over z. So that if you expand, you still get what is here. But what we have done here is that, because we want it to be like this, 1 over z for convergence. 1 over z. That is why we find a way of getting 1 over z in our expansion. And this will give me 1 over z squared into 1 minus 1 over z. This is 1 over z squared. If you expand this, just like what we have here, you see that the same thing. That will be 1 plus 1 over z plus 1 over z squared plus 1 over z cubed plus infinity. That is just like what we have here, this. But because this is ordinary z, that is why we have that. Now we have 1 over z. So if you expand, we have 1 over z squared. It will give us this. So this is the Lorentz series expansion. Let's take another example. Another example, we want to expand this in a Lorentz series valid for this. Absolute value of z is less than 2. So solution. So we have z minus 1 there. So as usual, you can use any letter. Let y be z minus 1. Therefore, z is equal to y plus 1. So our f of z will now become 1 over, this will be y squared into, our z is y plus 1 minus 3, which is equal to this into y minus 2. Now, this thing can be written as minus 2 plus y. You can still continue and write it as minus 1 over y squared 2 minus y. But we must have only 1 here. So that will be minus 1 over. And how do you do that? You factorize this out. That will be 1 minus y over 2. So that if you expand it, you still get this. So in this case, we are going to have minus 1 over 2y squared into, this thing is now in form of 1 over 1 minus x, which I have written as this. So in this case, our answer becomes 1 plus y over 2. The other one would have been y squared over 4, y cubed over 8, and so on. Now let's use this to multiply. We are going to have minus 2y squared. This is minus 1 over 4y. This is minus 1 over 8, and minus y over 16 minus infinity. But we have known our y to be z minus 1. This is 1 over 2 into z minus 1 squared, and this z minus 1 minus 1 over 8 minus z minus 1 over 16 minus infinity. So this is the required Maclaurin series. Now let's take another example. Example 4. Find the Lorentz series expansion of this, valid for the following. Firstly, our f of z is equal to 3z over z plus 2, z plus 5. So the first thing is that we need to apply partial fraction. And when we apply partial fraction, we should have 5 over z plus 5 minus 2 over z plus 2. Now let's keep that. When we apply the partial fraction, the first one says absolute value of z is less than 5. So if absolute value of z is less than 5, then absolute value of z is less than 2. So that means this and this are the same thing. They will give us the same answer. So in that case, our f of z is equal to 5 over, you can rewrite it as, okay, let me first write it out, minus 2 over z plus 2, which I can write as 5 over 5 plus z minus 2 over 2 plus z. When we are using less than, it is the number that will come first. Now, what we do is you factorize this 5 out like this. This is 1 plus z plus 5 minus 2 over, you factorize this to 1 plus z over 2. So this will give me 1 plus z over 5 minus 1 over 1 plus z over 2. You can now expand this. That is when you have 1 over 1 plus t. This will be 1 minus t plus t squared minus t cubed, like that. So this will give me 1 minus z over 5 plus z raised to power 2 over 25 minus z cubed over 125. That is that about that, plus infinity. Then minus, this one will give me 1 minus z over 2 plus z squared over 4 minus z cubed over 8 plus infinity. Then we can now simplify. When we simplify, this one is gone. We are going to have this. So this is our answer for both A and C. So for B and D, the same thing goes, but this is where we are going to start. For C, we have written this already. We have found out that our f of z is this. The next thing now is we are giving the validity of this expansion in z is greater than 5, which I have said before that it will be this for so it will be 1 over z is less than 1 over 5. Now what you just do is our f of z equal to, when you are giving greater than, this is what we use. You can see I did not interchange. I will leave my z like that, After I leave my z like that, in order to get 1 over z, I will factorize z out, so that our answer will be 1 plus 5 over z minus 2 over z into 1 plus 2 over z. When you are giving greater than, so it is the z that you are going to factorize, unlike the other one that will factorize the number. So this is 5 over z into, this will give me 1 minus, I've given you the formula, 1 minus 5 over z plus 5 square over z square minus 5 cube over z cube plus infinity, then minus this 2 over z into, this one too will be 1 minus 2 over z plus 2 square over z square minus 2 cube over z cube plus infinity. So the remaining expansion and simplification is left to you. But when we simplify this thing, which I don't need to show, when we simplify the whole thing, this one comes here and this. When we simplify the whole thing, we are going to get this. So we are going to have this when we simplify further. So the next one, which is E, is this annular region, valid in this annular region. So this simply means z is less than 5, z is greater than 2. Now our f of z has been found to be 5 over z plus 5 minus 2 over z plus 2. Now we are given z is less than 5. So what we do is, let me write it here. What we do is, we are going to bring 5 here. It is the 5 that we are going to bring because we are given less than 5. So 5 plus z instead of z plus 5 minus 2 over, but this one is greater than 2, we leave it like that. After that, you need to factorize this 5 out. This is 5 into 1 plus z over 5 minus, it is z you are going to factorize out because of the greater than, 1 plus 2 over z. This 5 cancels. What we are going to have left is 1 over this, and that is this is 2 over z dot 1 plus 2 over z. So that is what we are going to have. If you expand this one, we have 1 minus z over 5 plus z square over 5 square minus z cube over 5 cube plus infinity. This one is there, minus 2 over z into, when we expand this, we have 1 minus 2 over z plus 2 square over z square minus 2 cube over z cube plus infinity. So we now need to simplify this further, which you have to do on your own. When we simplify, we get this when we simplify it. So, and it's very easy to simplify. So this is the required Lorentz series in this annular region. And finally, in the region 0 is less than z plus 2 is less than 5. Finally, in this region, our f of z is given to be 3z over z minus z plus 2 and z plus 5. So sorry, in the main question, this is what is there, but that is not what is there. What we have is 0 is less than z plus 2, absolute value is less than 5. Then you can practice this one. Absolute value of z plus 2 is greater than 5. Now finally, in this region, when we are given this type of region, we don't need to use partial fraction here. So what you just do is you can let any letter, let it be z plus 2, then z is equal to y minus 2. Let's substitute everything here. So therefore, our f of z will be 3z. Our z is y minus 2 over, this is our y, into y minus 2 plus 5. So if you expand, we have 3y minus 6 divided by y into y plus 3. Now from this list, we have it to be 3y minus 6 over this y times 1 over y plus 3, which I can write as 3y over y minus 6 over y times, since we are given less than there, it is this 3 we write first, 3 plus y. And this will give me 3 minus 6 over y into, I've told you, you factorize. This is 1 plus this. And if we use this 3 to cancel this, we are going to have 1 minus 2 over y times 1 over this. So it's not left for us to expand this one. What we have is 1 minus 2 over y. Expanding this will give me 1 minus y over 3 plus y square over 9, that is 3 square, minus y cube over 27, that is 3 cube, plus infinity. So it's not left for us to just expand this thing. So it's very easy to expand. When we expand, we get this. When we expand and simplify, so finally we cannot put our y back. Our y is z plus 2. So when we put our y back, we're going to get this. So that's our answer. So these are final answer and the required Lorentz series expansion. So let's take the following and memorize them. Memorize this series, and these are the basic series we need in Maclaurin series expansion. So we are going to make use of it. That is what we have been making use of since. So memorize them and other series that you can memorize, so that it will help you in this Lorentz series expansion. Please have a good day.